Jetzt habe ich hier was ganz was Tolles in der Hand, ne? Was hat das mit Additive Manufacturing zu tun, meine sehr verehrten Damen und Herren? Da haben wir es. Das war heute Vormittag der Besuch von der Kanzlerin bei uns auf dem Stand. And I'm going to switch now into English because this is the preparation for our panel, which is starting right now, actually talking about additive manufacturing and the value it brings. Well, for sure, it brought a great value to our Chancellor Angela Merkel because she has a 3D miniature version of herself now for her shelf at home. And the Polish minister, she got a 3D bouquet of flowers, also wonderful for a setup and the memory of Hanover. And well, information about Hanover and the setup behind us seems to be prepared. Additive manufacturing is your topic, Carsten. You're the specialist in it. You're our head of additive manufacturing within Siemens. And you have a lovely, lively panel discussion now with 4 participants. I'm going to leave the stage for you. I'm taking Angela with me.
You're taking her with you.
My one.
Okay.
So enjoy the panel discussion. The stage is yours.
Thanks a lot. I would like to welcome our panelists here for our talk on additive manufacturing and driving the industrialization for additive manufacturing. Yeah, welcome, colleagues. So I just showed in my talk and that the complete value chain is partly within Siemens and together with partnerships with our customers. So I'm glad to have you here for our panel discussion because this chain here really represents the whole value chain of additive manufacturing. I'm proud that we have Andreas Saar with us. Andreas Saar is Vice President Manufacturing Engineering within Siemens Product Lifecycle Management. Welcome.
Welcome.
We have Uwe Ruttkamp. He's CEO for Machine Tool Systems within Siemens Motion Control.
Thank you.
We have our customer here, Martin Steuer, Senior Business Development Manager at EOS. And last but not least, a user and producer is with us from Power Generation. Professor Ingo Kelbasser from Power Generation, heading as the Senior Manager, Manufacturing Development and Industrialization within PG. Welcome to our panel. Welcome to you.
Welcome.
For this first round. For you, Andreas, the first question. To look a little bit, what is our base position, where we stand now? Where are we in terms of industrialization? How would you explain it between starting and being already there?
Okay, let's correct first of all a couple of things. We're not only presenting nice Angelas, but we're also producing real parts. And what I'm holding here was something Mr. Kaiser also was holding in the morning. This is a gas turbine plate, which our business unit of gas turbines has printed. And I would say this is the holy grail of industrial printing as we stand today, with an enormous complexity in the part, but also with an enormous achievement from an industrial point of view. And what does it tell you? I think there are 2 major issues we have to consider when we talk about industrialization of additive manufacturing. For me personally, I think there are 2 major things important. Digitalization is the first thing. We need to understand that additive manufacturing is a so-called digital thread technology. Without digitalization, additive is not possible. There's no way that we can move data into a printer from EOS without a digital thread in place. And as better this digital thread functions, as better results we can generate at the printer itself. So that's the first thing. Forget everything, digitalization is a must for additive manufacturing. The second thing is, we have to have an end-to-end solution to really make additive an industrial technology. We have to start in the design area where we, let's say, free up the minds of the engineers to create designs and optimize designs, reimagine products that can be better perform and that can really utilize the strength of additive manufacturing, because I can do things which I couldn't do before. And that is something where we're driving with our NX technology, design technology, but also engineering, the whole process which we just saw Carsten explaining, to make this whole process really an end-to-end, iterative, and first-time right process. And I think that's the two major things I would say help to industrialize additive manufacturing.
So Uwe, I think there's nobody who can better judge than you, because you're responsible as well for machine tool systems, those classical machine tool systems. If you compare this technology with now this new field of 3D printing, how would you judge the level of industrialization today?
Well, first of all, I would say, what is industrialization? Industrialization means that a machine is never stand-alone operating. It's always integrated in a line of other machines, because the process requires more processing than just the one machine, plus the machine and the machine lines integrated into the complete value chain of an enterprise. So this is integration. And for the classical machine tool business, there is no question. This all is there. Everybody understands that. Nobody will do it differently than running in an industrial environment with a cabinet being able to be shipped all over the world, in every country, have all the certifications. The machine is operated by everybody capable in the factories. It's a very mature situation. We are not as mature in additive manufacturing. Additive manufacturing comes from a world of standalone applications, but it has to go into the world of industrialization, as I explained. The second thing that determines the additive manufacturing technology is the capability of the designer. When a designer is able to utilize the full functionality of additive manufacturing, as you have shown in your pieces, then he is using the complete power of additive manufacturing. And that is not there. It is, for many cases, a delimiting factor in the enterprises today, that the designers don't have that knowledge yet how to utilize all these features.
So Martin, EOS, you're one of the pioneers from this technology. How would you describe the level of industrialization today?
Yeah, we see it, so EOS was founded in '89, so 27, 28 years now. And how we are seeing the world, that the first 20 years was prototyping. So, and that is what was already mentioned. The machines were used separate. They were used in research in a corner, and they were not yet in the production area. What we see since the last 7 years is that what we call the pre-production time, which means that you have small series production, that you have leading forefront companies like yourself, who is now going already in volume production, yeah? Who is printing hundreds of parts. And now we are at the edge with customers going into mass production. And like it was already mentioned, at the beginning, the quality of the part was important. In the last 7 years, it was the robustness of reproducing again and again the same quality, the same part was. And now we are getting from industrial customers 4 other challenges. One challenge is monitoring. Because we are going into the production, we need to monitor, and we need also to document how the process was done. We need integration, yeah, because we need to integrate into the MES systems, but we need also to integrate into the CAD/CAM CAE areas, because what is possible on the printer, the engineer needs to know. Yes, there should be not a restriction, but the engineer needs to know for what he is designing. Then automation is another big challenge we are seeing and addressing. And last but not least, also scalability, so that a customer can grow with our systems. He is starting with one, and then he can grow further and further. So we are seeing that we are leaving the pre-production area and entering into the industrial area, like with customers of yours and big other customers. We just announced with Premium Aerotech and Daimler to build one of the first digital additive manufacturing factories for aerospace and automotive industries. Yeah.
Ingo, would you agree to the judgment from the three colleagues here? Because you need to integrate all this stuff and produce.
Yeah. Carsten, the short version is yes. And now comes the more detailed version. I think, of course, it's hard to add anything right now because you are the last in the row as an end user. But I think from a first perspective, the burden and challenges we face every single day starts with the mindset of the design engineer. With the mindset. Because if you work in a field and you have optimized your one-end product, this blade one of an SGT 400 for, I don't know, 15, 20 years, and you tell the design engineer from today to tomorrow, now you have to change your mindset. From today on, you think additively. That doesn't usually work out. That's why we have certain operations ongoing in terms of education, training, etc. Second thing is you need the tools to think additively and to write it down and to sketch anything and everything additively. And therefore, we need a cooperation with you guys from DF, of course, with regard to new software tools, having the capability of real additive design. And in the end, of course, when it comes to interfaces, getting rid of these 4 or 5 different data formats from the design CAD file up to the printed and finished and good, to one and only PLM end-to-end communication, CAX framework with just one data format. And I think we have excluded one thing, and that is our own core competency is process know-how in specific materials. Because this material there is pretty hard to process in additive manufacturing. That's why I can't disclose here what kind of exact nickel-based alloy it is, but it is a nickel-based alloy, definitely meant for rotating parts. But this is really the core know-how we bring to the table, and that's why our enterprise and our department is called and area is called Manufacturing Development and Industrialization. But if you ask me where we are in terms of industrialization, we are definitely at the beginning.
How long does it take to print such a part in your machine?
Just a few hours.
Wow.
But it doesn't depend so much how many blades do you print. I mean, it's just mainly in the first approach a question of the height of the part. Yeah. Doesn't matter if you print one part or 70 parts, right?
Doesn't matter.
So it's mainly a question of the height of one part, and you can scale it up.
But coming back to intelligent software that you need to fit best like you can in this process chambers. But how do you cooperate with the colleagues here? I mentioned co-creation, co-innovation. Is this something which is active in your area as well with other partners?
Oh yes, I mean, I can give you one example. Last year, end of last year in December, we had a very open innovation competition at one university. That was the RWTH Aachen University. And we have asked students, hey, if you think completely free, without thinking in the first approach, can I manufacture that? So think instead of design for manufacture, think in manufacture for design. And they have come up with wonderful solutions, much more free and open than we could do it and our designers could do it, because they are absolutely free in mind. And this absolutely helps in terms of open innovation, innovation, co-creation, but of course that comes along also with a big question of IPR, intellectual property rights, because in the end the design is ours. Mm-hmm.
So, looking a little bit ahead, people would be interested, what is the strategy of Siemens in terms of additive manufacturing, as we have 3 colleagues here around? Would additive even make classical machine tool systems obsolete in the future? Uwe?
No, it will not. Additive manufacturing is definitely opening new opportunities that are not possible in classical machine tool operations, or you have to take so much material off the piece that it doesn't make sense from a material perspective. It's too costly, it takes too long to produce it. It opens new possibilities, but it is not taking anything away from the classical turning and milling processes, because that will still be there. You will still need a hole in a piece, you still need to polish it, you still need to manufacture it. So there are a lot of process steps that will not be substituted by additive manufacturing. But the thinking of the designer will make the possibilities on top of it so much more.
So I think many of our visitors have already seen that we have an EOS machine on our booth for selective laser sintering, as I learned. What is it all about? Why do you have your machine here on the Siemens booth?
One of the things is to show the integration, yeah? So that you're directly, without going through all these tools, that directly out of Siemens NX, you can set up everything. The engineer is getting already which of our machines he has selected, so he knows the build plate, yeah? But that he knows also which material is on the machine, which process parameters are on the machine. This is giving you which wall thicknesses, which holes, which angle I can build my walls into the free air, all these kind of things. That is designed for additive manufacturing, that out of selecting a machine, I already know what I'm able to produce. And that is something which we want to show here in terms of showing this kind of integration. Yeah? And in addition, I want to say also, it's really that, and often what we are seeing, customers are coming to us for a benchmark, and then they are showing us pieces, and it's a casting part. And the answer from us is really now, with this casting part, we cannot compete. You need to think about redesigning this part and thinking about the capabilities additive manufacturing have. And one of the things which we developed together as an example was this impeller improvement. For an impeller done in casting, I have everywhere same wall thickness. In additive manufacturing, I don't have that. This is giving the engineers the capability to do the turbulences into the walls, yeah? Or to make it lighter, make it with lattice structure or topological optimization. Yeah? So these are all the things which, starting with a part which is a casting part, don't come to us and say, print it, because then I need to tell you it's 10 times more expensive than if you would do it in a casting part. Think about what you can do, and that is exactly what I like, for example, in Finspång, yeah, about the burner repair, thinking immediately also about how can I improve the part by internal channels. So that's what we want to show here, this progress, what's done, and also how we have the integration into the Siemens NX world. Yeah?
But Andreas, if I understand the colleagues correctly, design and changing your mind for the designer is very important. Coming back, that's an issue, that you need the right software. So there's a lot of software around. What is unique on your NX suite?
So our strategy is clearly to integrate all the necessary elements in order to really come to a first-time right result in the printing process. And we've seen in the past a lot of companies who have developed certain modules and pieces in the additive manufacturing process chain, which are independently okay, and they do the job. But when it comes together to really integrate this, you run into a lot of limitations. You have different interfaces, you have different data formats, as you mentioned. The user experience is completely different. Engineers have to learn 4, 5, 6 different programs in order to get this whole process correct. And that is what Siemens PL, with our NX approach, want to really prove, that we can integrate that in one user experience down, integrating into the printer, and pulling all this information back, making that experience from design to the engineering, which is very important, which plays a big role to come to a first-time right thing, that we understand the process, understand how we layer metal and layer by layer, and how the melting functions, the material properties, characteristic, so that we really can provide our customers and engineers a real user experience from an end-to-end process, which is really leading to a first-time right result. And that's, I think, a huge change. No? It also means, by the way, that designers work with the engineers much, much closer together. The whole process in companies have to change between the way they work today, where designs are usually shown over the wall and you manufacture it, please, in really working together. And that's what we're trying to underlay with our software and solution approach.
We are always talking about customer value, increasing customer value. So looking a little bit in the direction of PG. So your customers, your gas turbine manufacturers, operators, what is the additional value you're bringing to the table with additive manufacturing? First question. And second question, in terms of customer value, looking into the round here, what is your wish? What is needed next for you from the value chain, software, automation, or machine tool systems?
Carsten, time is running. How much time do we have? No, not kidding. But I think from the customer perspective, of our customer perspective, purchasing these kind of components or entire power plants or gas turbines, it's mainly three drivers. It's cost driven, it's new functionality, and time to market. Taking that example you have mentioned, for example, that maintenance, repair, overhaul of these burner tips of an entire burner lance. That took in the past a certain amount of time, and we could decrease the time to market. So delivering the spare part after incoming order, we could decrease that time by 90%. So that makes sense. If you think about this blade, for example, that is a test rig blade. We can't print it out in a serial manner right now. We are further down the road, but we can't do it yet. But what we can do with this kind of 3D printed blade already is equipping a test rig that enables us to also decrease our test and validation cycle by 80–90%, coming to with a new product to the market in just 10% of the time. So time, cost driven. The first serial part we have introduced mid of last year. That was a burner head as a spare part, new part manufacturer, not MRO, but new part manufacturer. That was, the same design was also manufactured in the past via a cast route. And now you have to imagine it is also a kind of cost if you think about substitution of conventional manufacturing routes. Because additive manufacturing is not just one process step. It is not just powder bed fusion. It has a design phase, it has a preparation phase, it has the additive manufacturing process step, but you have, of course, post-weld heat treatment, you have finishing operations, you have your supply chain. So by shortening all these different, in this case, AM routes, you can also decrease the cost. And of course, introducing new functionality, staying with that kind of example there, you have just two different options to increase the efficiency of a gas turbine from a thermal electrical point of view. Increasing your firing temperature, decreasing your, let's say, cooling fluid consumption. And you can't just do it by new case or using new materials, high strength, high temperature materials, and by using, for example, new designs that enable you for a new, more efficient cooling. And that's what you do with additive manufacture. You can think in absolutely new ways of redesigning conventional, in this case, turbine blades, to redesign your cooling channels to come up with a much more efficient cooling. And then you increase the efficiency, and the customer of ours, the client, will be definitely saving, in this case, usually fossil gas, in order to run and fire these gas turbines in a combined power cycle plant. What is absolutely crucial for us as being the end user is that strategic cooperation with software, with integration, with line integration, MES systems, again, PLM end-to-end, because if we want to accelerate our innovation cycles, if we want to accelerate our time to market much more, then there is a huge potential. And I personally believe that the biggest potential in additive manufacturing can just be deployed by coupling that with digitization efforts, with digital twins, with also the ability at least to carry out and to conduct in situ process control.
Yep.
Because if you could do it, then you can save also subsequent process steps such as NDT, so non-destructive testing. But we are not there yet, but there's a huge potential in there.
But Frank, if I listen to Ingo, it seems there are more steps than just the only machine for 3D printing. Where do you need help, or where do you get support from others? What is your core competence? Is it the machine, or will you spread in other areas as well? Post-processing or powder handling?
So our core competence is laser hits the powder. Yeah?
Okay.
So mastering the process, mastering the laser, and getting out of powder solid metal. That's our polymers. That's our core competency. Where we are getting a lot of help or experiencing is in this kind of cooperation. As you can see at our booth, yes, we have visions in terms of how the additive manufacturing factory or production of the future can look like, but only with customers and also with other partners, you can feel and experience if this is really becoming reality, what you have envisioned, yeah? Because you are not thinking all the things which can come into account. So for us, it's quite important to be part of this team to make this robust so that more customers can really then take advantage of additive manufacturing for new business models. And one of these business models is really spare parts, yeah? That you don't have a huge stock of spare parts, that you can think about, I put the printer in the near of the gas turbine factory, and I can print the spare parts directly in the near so that I can get the downtime to a minimum for my customers, yeah? Or other things. And that means everything we already talked about. We need to integrate our systems. We need to help with processing, yeah? We need to help also developing new materials, which was already mentioned. And that is for us, again, to come back, we are not only a machine vendor, yeah? We are providing also material, and we are also selling the providing the process parameters. Because in our eyes, it is quite important to get our customers very fast up to success. Yeah? Our machines are not cheap, yeah? So that's one of the things. But a medium-sized customer is not afraid of investing 500,000 or 1 million, because he is used for milling centers or other production centers. He is fully aware that this is the amount of investment. The problem with additive manufacturing that it has this reputation of I need 6 months, 9 months, 1 year until something is coming out. And through our integration and through providing together material and experience, we need to get this down that our customers are in 2 months up to speed and getting out the first parts. And then we will go into industrial manufacturing. And I think we are on a very good way together to show that to customers with more and more examples. Yeah?
Wow, up and running in 2 months. So looking on control systems, automation systems, how do you convince your customer to really take up our portfolio here in this regard for the additive manufacturing machines?
First of all, our portfolio for additive manufacturing is not different from the portfolio for conventional machines. It's a comprehensive automation portfolio that Siemens offers, from control over HMI to IOs. It's all there. And it's a matter of applying it, it's a matter of programming it, it's a matter of putting the right pieces together to use it for additive manufacturing. And we are, of course, helping our customers to get there, to build a control cabinet that can then be used all over the world, fulfilling all certifications. But now comes the important part. The important part is that an additive manufacturing machine uses a material. which comes in powder. So powder is completely different to handle than long sticks of metal. From a tracking and tracing perspective, from the way how to manage it in your stock, how to move it to the machine, it's completely different. So the automation as a front end of a machine to handle that is a new part. That is something that we develop together with OEMs to make that industrial, to automate that. And then, of course, once a piece is printed, it needs to, maybe heating process is necessary or a cleaning process to get rid of exhaustive powder. That's another important separate step that is usually not done in the printing machine. Can be, but it sometimes is not. So it happens aside of the machine. And there again, the comprehensive automation portfolio from Siemens is then basically accompanying the core process of additive manufacturing. So the additive, the printing part, is only one part of it where the complete automation equipment is used. All the rest is sometimes different, sometimes the same as in the classical CNC business. And Siemens has it all. It's all there, can be used.
Let's come to our third block. A look a little bit ahead in the next years. And one question to Andreas. Today, I think you announced a Siemens pad manufacturing platform.
What's
Just explain, what is it all about?
Okay, let me say that first. We heard today and through your presentation and the panel discussion that we're on a good move. The technology is moving forward. It's stabilized. We have a lot of material research. Industrialization is a big topic. We all know to drive this forward, it's important. So the technology itself and the industrialization, I think we have a good picture to it. The question now comes, how do we really accelerate adaptation of that technology in all industry across the world, really in regions where we might not have an industrial country like in Germany, where we're far ahead maybe. So in order to do this, we need to bring people together. We need to bring engineers, expertise, in a way, to people, to countries, to engineers who really want to learn, understand, co-create, co-innovate their products, but maybe have not the access, not the real means to come to this technology. And that's what this platform is all about. It should allow to bring all the players who have know-how in this area, if it's an OEM like EOS, who has really understanding of that technology, the process, the material vendors, a supplier who wants to have wants to print parts, to a buyer who maybe has a need, to engineer and services who want to help to optimize parts, because the person may not have the know-how to do this. Bring them all together, work them, explode this, and explode it worldwide into all industries. And I think this wonderful technology needs to be accelerated in the adaptation. And that's typically a huge hurdle, because spreading knowledge is not easy. And with a new part manufacturing platform, we want to make this easier. We want to make this information available through the web, through cloud technology, make it available everywhere where I am. And I think this is a great way to move this forward. And we're really, really excited about this.
Really great approach. How would you feel about it? Would it help you? Does it seem to be interesting, Ingo, Martin?
I agree. It is necessary, yeah, because you need to have a community which is working together. Because, as I already said, it is not only the machine vendor; it's material. It's also others on a process. And I could now pick out my mobile phone. Yeah, look at this. This is an app where you have a platform where you provide more apps on top of it. Why not? we have a lot of metallurgists and things, but we will not be able to invent in the time and amount new materials which we could do in this kind of area. But it's a business model you can use. We can start to say this can run on an EOS machine and it is certified, for example, so that we give also an additional value to customers. Yeah, like Andreas was already saying, not everybody has this expertise. So crowd sourcing, or engineering, that you are finding people who have this knowledge is an area where such kind of platform is available. And even out of my trusted environment or my environment I'm used to in Siemens NX, that I can fast go to getting additional help. So it's definitely something we fully support. Yeah.
Ingo, you're a lot activities away in different communities. You work a lot with universities, with cooperation partners. What is your first reaction to this announcement today?
My first reaction is it's definitely a good way, because you need to establish networks. You need to establish networks of people that can help you bringing and implementing that AM DNA and spreading it outside. And I think what we have seen also in the past in additive manufacturing might be that also correlates with your experience. You need to leave your comfort zone. You need to leave the ways we're working from the past with these disruptive technologies. Yep. This is not just AM, this is also digitization. And with all these disruptive technologies, we need to leave our comfort zone. And we need to leave it, and we need to talk about also cooperating with our biggest enemy in order to come forward and in order to spread that knowledge and that AM DNA. And I would like to add something to Uwe's, what he has mentioned before, totally integrated, what did you call it? Totally integrated automation. Thanks. Totally integrated automation. That is, for me as an end user, a wonderful idea. And we need to consider a second point. I think it's great to have a first pilot line somewhere in Berlin, for example. But what we face as a problem every day is we need to transfer these solutions to everywhere in the world. Doesn't matter where we have our AM footprint. So that means that the same solution, totally integrated automation running in Berlin, needs to run also in Finspång with, I don't know, X machines, and with Y machines in Worcester at Material Solutions. So everywhere we have our, let's say, AM footprint needs to have that kind of totally integrated automation solution in the end, because otherwise we struggle again. Because what we need is a standardized solution, doesn't matter where we are.
So one last question, whoever wants to pick it up. Additive manufacturing, if we look further down the road in 5 to 10 years, now we see this kind of machine. How would you describe and how would a fully automated production line look like? Is there any person working on it? Is it fully automated? Is it large production capacity? Who has an opinion? How is additive manufacturing look like in 5 to 10 years down the road? What are additional trends coming up in this area?
So you can see our vision at our booth, which is that you have hundreds of printers feeded automatic by automated vehicles in terms of bringing the new chambers to them, so that the process chamber is 24 hours, 7 days a week in production. We see that this is like in traditional manufacturing. This can be highly automated. It depends on the use case. Yeah? If you have the requirements that you need to produce 5,000, 10,000 parts, then you will have it fully automated. In other areas, you will have it semi-automated, yeah, like it is today, where you have highly 5-axis work cells, but they are still fed by operators because the thing is so often changing. Yeah? I think with these kind of huge manufacturing farms, we are coming to the reality of one piece production, so lot size 1, because the printer doesn't care if the neighbor part is a little bit different than the other one. So we will get even more customization to each of the individual parts. So that is definitely something I believe in, that in the next years is coming. And in addition, also for Industry 4.0, what is also important is to partner and to work together with others, because to show the agile and fast delivery of new part, you don't have the time to program, to develop everything by yourself. So you pick pieces and things together, and then you form out of these different pieces something new. And that's something I like out of Industry 4.0, because all the foundation is already there since years. Yeah, it is infinite computing, cloud storage, it is cyber physical systems, and also protocols is already there. What is things we need to think about, how to put these pieces together to come up with a new business model or offer something new to the customer. And in our eyes, we are seeing it also what is a little bit coming from the aviation flight industry, power by the hour, yeah, that we think about print by the hour. The customer is asking us for 10,000, 50,000 print hours for the years, and we are taking care that this is available. Yeah.
So a lot of stuff coming and trends coming up. And for those of you having been around in the morning, Klaus Helmrich mentioned it as Industry 5.0, something like this. They've had a spider here on the table, which was by itself printed. And this spider was moving around, and it was a 3D printer built it into the spider, that you can build it in somewhere parts in manufacturing in harsh environment. So even there more and fascinating technologies are coming up. I would like to thank you, and I think a big applause to our panelists.
Thank you.
If you have further questions, I think the colleagues are around at our highlight cube after this panel discussion. Thanks for coming.
Thank
Goodbye.
you, Carsten. Thank you, Carsten.
Thank you.